Okay, welcome to week 3. Um, we are going to be starting looking at atomic theory. So, we're going to be looking mainly at the history of atomic theory this week, and then next week we're going to start looking more so at what we know about the atom. Now, um, I will just let you know there are a few kind of complicated procedures, experiments in this week's information. Um, I'll do my best to explain them, um, but don't want you to stress too much about the actual procedures of how they proved these things. It's more kind of knowing some of the changes that occurred and what each scientist added to atomic theory. This week, you're going to do just a little small poster project. We're going to look at the contributions of several different scientists. So you get to choose one scientist and just talk about their contribution to atomic theory. So that's the biggest part. It's not whether you remember what an alpha particle is, because we're going to mention things called alpha particles. It's going to be more so that you can describe what Ernest Rutherford did to contribute to what we now know about the atom. Okay, so let's dive into the history, and what's a better place to start than our key concepts. So, number 1, Dalton developed an early atomic theory. You don't know who Dalton is yet, but you will. He's kind of a big name in chemistry just because he really got scientists thinking about atomic theory. And then, next one, many scientists contributed to the further development of atomic theory. So that's going to be the biggest focus, and the biggest focus of your project this week. Sorry. Okay. So let's look at those Greek philosophers. And this is he doesn't look too friendly here, Democritus. But Greek philosopher Democritus, he proposed the idea that matter was made up of tiny particles that exist in empty space. And that might sound similar to our kinetic molecular theory and some of the points in there. So he called these tiny particles atomos, and that means uncuttable, because they could not be created, destroyed, or divided any further. So Democritus wasn't using any actual physical scientific tools. He just used reason and logic to come to this point. So he's not really one of our scientific contributions, but his thoughts definitely got some scientists actually thinking about those particles that make up everything. So here's Dalton. This is John Dalton. In the early 1800s, there started to be support from experimental results and analysis that made this atomos idea reappear. So John Dalton started performing experiments, and they allowed him to develop and refine and support a hypothesis about matter. And in 1803, he proposed his own atomic theory. So you're going to see some stuff in this atomic theory that we do still agree with, but a lot of it has been refined further. So, Dalton's atomic theory. All matter is made of extremely small particles called atoms. Atoms cannot be created, destroyed, or divided. All atoms of the same element are identical in size, mass, and chemical properties. Atoms of a specific element are different from those of another element. Different atoms combine in simple whole number ratios to form compounds. In a chemical reaction, atoms are separated, combined, or rearranged. So this is his atomic theory. We have small particles that make up everything. and we cannot create or destroy them. Okay, so this is what we're starting from, and we're gonna, as we go through, see what parts are getting changed by each scientist and what they did that supports them making that change to atomic theory. So next up is J.J. Thomson. So he was a British physicist who studied electric currents in cathode ray tubes. It was more interesting to mention cathode ray tubes, I imagine, when that's what TVs use, but they don't anymore. So it's kind of an older technology in lots of ways. So scientists had discovered that when they attached a battery to the tube, a ray traveled through the tube. Further experiments revealed the following. So cathode rays were streams of negatively charged particles, and all substances produced these particles. So every substance was producing negatively charged particles. So let's look at this diagram. So this is a cathode ray tube. So you have a battery here creating the voltage, and and electrodes that generate a ray. So here is a negative charge of the cathode, and there's a positive charge here, and this is the ray. So they were able to tell that it was negatively charged because it moved away from the negative plate and toward the positive plate, which is this whole idea with like magnets and things where it's the opposites attracting. So basically what they discovered is that there must be some negative charge in an atom. So Thomson created his own model of the atom, and now we get a beautiful picture. So he found that the mass of the charged particles was smaller than an atom of hydrogen. So this meant that there were smaller particles than the atom, and it contradicted Dalton's theory that atoms were the smallest particle. And basically, Dalton was thinking that there was nothing in there kind of making up the atom, that it was just the atom. Thomson is saying that there are other particles within an atom. So Thomson developed this plum pudding model, that a positively charged ball, so this orange circle here, with negatively charged electrons embedded in it. So usually when I mention the plum pudding model to students, they're like, what's plum pudding? Why are they saying this nonsense? Pudding is basically what you call dessert in Britain. And Thomson is British, so he said it was plum pudding. And just to, I don't know, help with your curiosity, this is what plum pudding looks like. So I guess it works, but if you can think of a better food item, let me know. Okay, so this is Thomson's contribution to modern atomic theory. Atoms are not indivisible, and that they contain smaller, negatively charged particles, now known as electrons. Okay. Okay, so we're done with Thomson for now. Now we get to check in with our good friend Rutherford. So Ernest Rutherford and the nucleus, not a word we've seen so far, have a hint of what he maybe discovered. So Rutherford did this experiment where he exposed a very thin sheet of gold to a stream of high-speed particles with a positive charge, and he called these particles alpha particles. Well, I don't think he was the only one that called them that, but these alpha particles acted like tiny bullets. So the idea is that they were going to go straight through these thin sheet of gold. Rutherford wanted to see what would happen to the alpha particles when they made contact with the gold atoms. So he surrounded the gold foil with what was called a detector screen, and the alpha particles would become visible whenever it struck the screen. This all sounds like nonsense. Don't worry, I have a diagram. So here's the source of the alpha particles. So they've got lead around it because alpha particles are radioactive. And so we have the alpha particles shooting towards this gold foil. And this is the detector screen that's basically telling you where the alpha particles ended up. And what we see is that most have gone straight through, but a couple of them have rebounded backwards. So the result was consistent with Dalton's model, but the surprising result was a small percentage of the alpha particles that rebounded from the foil. So the idea was that if it was this ball with just the negatively charged portions, they all should have gone straight through. So what Rutherford had discovered was the nucleus, this tiny, dense, positively charged center of the atom. So what was causing those rebounds was this nucleus. So by 1920, it was discovered that the nucleus contained positively charged particles that Rutherford called protons. So at this point, we have negatively charged particles called electrons and positively charged particles called protons, both within an atom. And then we kind of have a side note here of this guy, James Chadwick. He found that the nucleus also contained neutral particles called neutrons. So Rutherford and Chadwick's contribution to modern atomic theory. So that the vast majority of an atom's volume is empty space, occupied by very tiny negatively charged moving electrons. The positive charge in an atom is contained in a tiny, dense nucleus. The nucleus is made up of two types of particles, each with about the same mass: protons, which are positively charged, and neutrons, which have no charge. Protons, positive, neutrons, none. Okay? And now we're going to talk about a guy called Niels Bohr, which is not the best last name. So Niels Bohr worked in Rutherford's lab, and he studied electrons and the region around the nucleus. So this was the area that they said was mainly empty space with moving electrons around. He analyzed the light released by various gases and knew that the light emitted by the gases was a result of high energy electrons releasing energy. He wanted to know why the electrons of a given gas only emitted light of certain wavelengths. So, usually I would in the class, because we talk about wavelengths of light in the physics section as well, we would look at basically putting electricity through certain gases and seeing what colors we get. So we'll probably look at a video of that when we get into the physics portion, but just kind of keep that in mind. There are some ties here with what we're going to learn about in physics. Okay, so Bohr wanted to know why the electrons of a given gas only emitted light of certain wavelengths, which essentially is certain colors. So Bohr proposed that electrons surrounding the nucleus, so over here we got the nucleus and we got electrons, that they could only occupy specific energy levels or energy shells. So we had some electrons in different levels. And he proposed that the larger the shell, the higher the energy of an electron occupying it. So the more that you moved outward, the more energy the electron had. And that is basically it. When we pick up next week, we're going to kind of talk a little bit more about our friend here and how things moved along. But where we have left off is we have a positively charged nucleus, but it has protons and neutrons, which have no charge in it, and that we have different energy shells, energy levels that have electrons. Okay. So this week it's just the one little poster. You're looking at contributions of different scientists to atomic theory. And next week we're going to continue talking about atomic theory and kind of where we're at with it now. I will be doing office hours again this week, so the invitation will be in the email that you received today. I hope you all have a good week, and just let me know if there's anything that you need when it comes to help or anything like that. Have a great week.